Identify the thermodynamic process occurring in the vessel. When liquid methanol, CH3OH, is introduced into a previously evacuated, rigid vessel at 300 Kelvin, it immediately begins to evaporate, vaporize, into the empty space to form methanol gas, CH3OH. This process continues until a dynamic vapor-liquid equilibrium is established, which is signaled by the pressure leveling off at a constant value of 0.196 atmospheres. Classify the phase change as physical or chemical. A change of state, liquid to gas, is fundamentally a physical change rather than a chemical change. The chemical identity, molecular formula, and arrangement of atoms within each individual methanol molecule remain completely identical before and after the transition. Analyze the microscopic forces at play. In liquid methanol, individual molecules are held close together in the condensed phase by a network of intermolecular attractions, specifically London dispersion forces, polar dipole-dipole interactions, and strong hydrogen bonds between the OH groups. Determine what happens at the particulate level during vaporization. For liquid molecules to escape into the gas phase, they must absorb sufficient thermal energy to overcome these intermolecular attractions. Once these attractive forces are overcome, the molecules can separate and fly freely as gas particles. Differentiate between intermolecular and intramolecular forces. While the weak attractions between different molecules are overcome during evaporation, the strong intramolecular covalent bonds, the C, H, C, O, and O, H bonds holding the individual atoms together inside each methanol molecule, remain completely unbroken and intact. Conclude, because evaporation is a physical change in which intermolecular attractions are overcome while intramolecular covalent bonds remain intact, option D is the correct answer. The correct answer is option D. A physical change takes place because intermolecular attractions are overcome.